Welcome to a GradTrack event. You heard about GradTrack? All right, a couple of us have. This is our library effort to be more attentive to the needs of our grad students and to help them out with some things. And so this is a special workshop sort of targeted among the pitching across the grad student plate, so to speak. Sorry, World Series members. I'm from around Houston, so go ahead. Big event in the U.S. today, or last night. Also, it is Open Access Week. Have you heard of Open Access? Have you seen our table downstairs with the big sign that says Open Access? Maybe you had a cupcake. That is an effort. Come on in if you like. You're welcome, welcome.
Yes.
Just getting started. So Open Access is an attempt where libraries are heavily involved to work with our faculty to make mostly the publications, but also data, which is what we'll be talking about tonight, to make those things more available worldwide without a fee, without a cost to the person who wants to use them. So we connect this event with Open Access Week as well as GradTrack. And how many other umbrellas are we under, I guess? I guess that's good. Yeah. Grad research workshops or something maybe. Yeah, all kinds of things crammed into one. But I'm happy to talk to you tonight about open data and research data management. So, what's wrong with this picture? Just a little. This is data people humor, right? Some people start with cartoons, and data people start with funny graphs. So I think that's from the Daily Show. That's what somebody told me. Don't know the citation, but it's fun to think about. Subdividing one into a partial crime. I don't know. So here's what we're going to do. And now I'm assuming a research academic, we're on a college campus, we're mostly talking about academic research data. So we'll talk about the data problem in that context, data life cycles, on campus especially. And then I'll kind of go out to the broader context of what we call business intelligence, business being how people do things in their field, and how data works in an ecosystem nowadays. We'll talk about data sources in general, because that's sort of was the point. General and some specific academic research data resources. Then we'll go into data tools, a little bit of a demo of OpenRefine, and I don't think tomorrow I'll be doing a workshop just on OpenRefine and Tableau together. And you will be given a license if you come with a laptop, and you can play with it for at least the end of the semester, maybe longer. I forget the exact term. But Tableau we won't do together today. You have to come tomorrow between 4 and 5. Same place, right here. But I will mention some other things related to Tableau that will kind of, I think, pull all of this together. Okay? And then I will go through sort of what we would call an introduction to research data management, which, with the context of what we go through before, should apply some of the new parameters, new requirements. We'll see what is going on in that field. Okay, so here is the problem in a nutshell.
Hello, my name is Dr. Judy Benign. I'm an oncologist at NYU School of Medicine.
Hello, Dr. Judy Benign.
I read your article on B-cell function. I think that I could use the data for my work on pancreatic cancer.
I am not an oncologist.
I know, but I think I could use the data for my work on pancreatic cancer. Do you have the data?
Everything you need to know is in the article.
No. What I need is the data. Will you share your data?
I am not sure that will be possible.
But your work is in PubMed Central and was funded by NIH.
That is true.
And it was published in Science, which requires that you share your data.
I did publish in Science.
Then I am requesting your data. Can I have a copy of your data?
I am not sure where my data is.
But surely you saved your data.
I did. I saved it on a USB drive.
Where is the USB drive?
It is in the box. It is in the box at home. I just moved.
But can I use your data?
There are many boxes. So many boxes. I forgot to label the boxes.
Hello again. Thank you for sending me a copy of your data on a USB drive. I received the envelope yesterday.
You are welcome, but I will need them back when you are finished. That is my only copy.
I did have a question.
What is your question? You might find the answer in my article.
No, I received the data, but when I opened it up, it was in hexadecimal.
Yes, that is right.
I cannot read hexadecimal.
You asked for my data and I gave it to you. I have done what you asked.
But is there a way to read the hexadecimal?
You will need the program that created the hexadecimal file.
Yes, I will. What is the name of the program?
Cytosynth.
I do not know this program.
It was a very good program. The company that made the program went bankrupt in 2007.
Do you have a copy of the program?
I do not use this program anymore because the company that made it went bankrupt. Maybe you can buy a copy on eBay.
I have good news.
You again.
I talked to my colleague. She knew a person with a copy of the software.
Then why do you need me? Everything you need to know about the data is in the article.
I opened the data and I could not understand it.
If you have the program, you will find it is clear.
Well, I noticed that you called your data fields SAM. Is that an abbreviation?
Yes, it is an abbreviation of my co-author's name. His name is Samuel Lee. We call him Sam.
I see. And what is the content of the field called SAM1?
Ah, yes. SAM1 is the level of CXCR4 expression.
And what is the content of the field called SAM2?
That is logical if you think about it.
What is the content of the field called SAM2?
I don't remember.
What about SAM3? Is there a guide to the data anywhere?
Yes, of course. It is the article that is published in Science.
The article does not tell me what the field names mean. Is there any record of what these field names mean?
Yes. My co-author knows what the content of SAM2 is and SAM3. And SAM4.
Can I talk to your co-author?
I'm not sure.
I would very much like to talk to your co-author.
Well, he was a graduate student. He went back to China 2 years ago.
Can I have his contact information?
He is in China. His name is Sam Lee.
I think I cannot use your data.
You could check the article to see if what you need is there.
Please stop talking now.
All right, so that's the problem in a nutshell. We could catalog all of the issues that came up, but he keeps trying to sell that article as the definitive measure of the data, right? And just doesn't work. So here, let's think about the whole environment of data curation and the lifespan of data. So when we're starting, a project or a research endeavor, we have something, we come up with an idea, and we create, and maybe we receive, maybe we use some other data from somewhere else, and we put together our project once it's done, and then we decide kind of at the end of the project what we're going to keep. We appraise and we say, oh, well, that stuff There's a lot of personal information that I don't need to keep anymore, and it's only a liability. I'm going to get rid of it, so we may get rid of some things, but we appraise what we have and we select what we want to keep. And then we need to put that into some database or repository, we might call it, and ingest it. And in those conditions, we have some preservation actions that we use to verify that file, that it is what came in the first place, and over time we verify that it has not changed and nobody has gone in to alter it or anything. We store that information over time, and then some people might want to look it up. They Google it and they find, oh, that we did the same kind of research, and they grab our data and they access it, they use it, and they may take some of it out. She only wanted a few columns, right, in the video. She wanted to save some of his work. So maybe we're slicing part of someone else's data and combining our own. Maybe we have another source that we're pulling in to do our research. So then that's transformed into a new project, and the whole cycle begins again, right? So there's a lot going on in the middle to make sure everything is valid and has integrity over time. So that is more of the research system, ecosystem. So here is the ecosystem from this is Computer World, so a trade magazine, you know, not an academic journal, but it's just about the current state of what's going on in with what we might call big data today. So basically, data comes from somewhere, and then we have to do something to it to be able to manipulate it, to be able to use it, and then we want to apply it, or maybe visualize it, to put it into some graphic form that we can consume. So in an organization of any size, including academic organizations, maybe your human resources data is in Oracle, so HR data. Maybe you track what you do with your website, and you're following that with Google Analytics. Maybe you have alumni or customers that you're managing with, you mail out emails to them, right? And you're using MailChimp for that. And you want to know what was effective and what resulted in a response that you liked. Maybe you're using data.gov. You know, the federal government produces a lot of data, even states and cities now. So much of that is online, especially things like real estate and public health. So all sorts of things that you can pull in. But to make all of these different things work, you might need a tool that allows you to put the columns and rows such that you can make sense of the data. So that's what this is. And that's OpenRefine that we're going to talk about in a moment. It kind of goes in this column. So then the application, they call it an insights tool. You want to be able to pull out facts or traits that stand out, right? Salient features from your data. And so you're probably using, do you use R in physics and space science? What's your tool?
Python.
Python. So some scripts, and a lot of those are, a lot of these things can be done in the scripting world, or you may want to create nice little visualizations, which is what Tableau does, and along with a lot of other tools here that are possible. Okay, so you got the data from somewhere, you did something with it, and then you kicked something out to show. And so let's talk about some data sources. I thought it might be fun just to go, I mean, so the kids nowadays, they just Google it, right? So here are some recent things that I looked up. Of my Googling, here is something that looks pretty good. Infogram is connected with Prezi, the presentation tool. Their companies are related. But they've organized this nicely. Maybe we'll get this on LabGuide or something. But so there's government data, and again they have the federal data there, data.gov, for example.
Make it a little bigger.
So let's see, crime information, not just US data, but there's European information, UK. Australian data. There are facts you might want to know about the world, UNICEF and UN and World Health, financial data, World Bank, all of these sources you might, depending on your field, maybe don't go to finance data for physics, but who knows, maybe there's some application. Actually, one of my roommates in grad school he was doing his PhD in astronomy and went to work for a financial firm. So you never know. So, being able to deal with the numbers and manipulating things. So there's academic data. Probably most of you know Google Scholar. So nice categories on science and health and weather. Of course, social media is important these days, so marketing, trends on Google searches, Facebook and Twitter and Instagram and Foursquare APIs, some data that's available. So there's so much, and at the end I'm going to show you some things that kind of pulls all this together from a Tableau example, why these might be important. Specifically, people are doing sentiment analysis. I noticed a friend just today posted on Facebook that she's getting the flu. So these sorts of things, once they go into Facebook or Twitter, you know, uh-oh, the flu is spreading. People watch how the flu season goes every year by following social media. So let's see, news sources, again, this will be related to what we look at the end. And Amazon Web Services has all kinds of different things you wouldn't think of. And there's, if you like movies and cultural information, that IMDb is related to the movie industry. And so there's a lot of, like it says here, tip of the iceberg, just some things that you might not think you would pull these things in for academic research. But like I said, with the flu season, those are actively being used for like public health analysis and stuff. Okay, so that was sort of a general thing that you might use. What about from the academic world? Now here's the link to the site, but I wanted to show you how you might get there, because it is on one of our guides at the library. So let's look at how we have created some information for you. So this is our library website, lib.fit.edu. And our research guides, we have a link over here and a link over, let's see, here. But they all take you to these special guides that we have arranged by subject and sometimes by course, and maybe recognize some of the people in the room. All right, so data management is one of our sites, one of our live guides, one of our guides. So research data management, and let's see, I was gonna do Ray 3, and that is in this tab down below, I think.
On the right side.
Oh, there it is. Maybe. So that's how you would get to it from the live guide, or just ray3data.org. And since it was originally German, I don't know if they call it GradTrack data or actually it's, you know, like cubed 3 instead of, so I'm not sure how you pronounce it. I call it Ray3 data. But let's see, let's say somebody might be interested in robotics. Let's see what kind of robotics data we could get. Well, look at that. Cornell has some stuff out there, Carnegie Mellon. So several types, several instances of data. But look at their guide to the sites, the individual sites. They have a nice key to what's in there. So the little I means they have additional information. You might want to do some research on, you know, what's this site about. Here is our nice little open access symbol, the unlocked lock, and that says that there's not a fee to get in there. It's open access data. The terms for using the data are available, and if they have a persistent identifier, for example, this one uses DOIs. It's important in citation, so you want to remember where you got this stuff from, right? So we have these permanent identifiers like DOIs that will take you back there. Not all of them do. What does this one have? Doesn't say, but could be a DOI, could be a handle, could be an ARC, could be a couple things, a couple other things. So certification is important, or was considered important. It's now seen as a really huge hurdle for a lot of places, but it's something that a lot of us aspire to, even if we are not yet certified. But maybe down the road, in a few years, you'll see more sites being certified according to a standard that says they have these policies, they perform these activities to preserve the data. That's how we know that this is a reliable repository. And then the last one is whether they have policies. So Carnegie Mellon, they do have some policies about using their data. So that is the best sort of academic research data repository source. So it's not for searching for specific data sets necessarily. This is to find places that have your kind of data. So we always like to see a lot of tags, you might call them, metadata, subject guides to what's in that data repository. So if you go and create one, make sure you have a lot of nice tags so that we can find out how to use them. Oh, the guide to Florida Tech options. So back at the Lib Guide, I have that under backing up your data. Recently, this has been approved by what we call one of our governance committees, our academic computing governance committee on campus. And a lot of people don't even know what's available when they're doing their work. You're doing research, and you may think, oh, I have to use a thumb drive or something. But in fact, there are a lot of options, especially on campus. So, do you know about your U drive? Have you used your U drive? When you log in to a Windows machine, there it is. It follows you around. And you can actually get to it online, anywhere, from anywhere, with an internet connection, at cloud.fit.edu. It's not well advertised, but you can get to your U drive. 500 megs per student, 1,000 megs per faculty is the current max. The size limit is a huge limiting factor, something definitely to consider. But I've given you a couple of parameters here to help you decide what's good, what fits your case. So GitHub, any of you write code? Python folks probably, do you use GitHub for
I don't, but some of our
Yeah.
colleagues do.
Mhm. So you've created this script, and then your colleague says, oh, I think I'd like to do something similar, but I want to change one thing. So you say, okay, I'll fork it over here. So I take what your colleague had, and you fork it and change the one thing you wanted to change, and, you know, Bob's your uncle, as we say. In, I don't know where they say that, but some people say that. My Uncle Bob used to say it. No, I don't have an Uncle Bob. So let's see, go.fit.edu is your Google Drive. So I have distinguished here the Google Drive space you get through FIT versus what you could get off the street. That is to say, without connection to Florida Tech.
Excuse me?
Yes, sir.
It says that it's not a long-term solution.
Right.
Means like it will expire as our graduation.
When you leave, yeah, it's gone. Your GitHub's gone.
So we have to secure this, download all the data and save it.
You need to do something with it if you want to keep it. That's right. So what we're going to try to sell you, not sell you, but convince you of, is that if there's something that you want to keep, you come to talk to us at the library. Because we have a space for, especially what we mostly use the scholarship repository for right now. Are you doing a thesis or dissertation?
No.
If you were, if you're a grad student, you're doing your thesis or dissertation, it will go in there. We don't deal with paper much anymore. You don't have to do paper. You have to do this. If you have data, large data sets, we might put it in the repository, but Dataverse is a solution we're trying to think about for cases that need it. And it has been beta tested, which you can check out at this site. Let's see. So I was talking about Google Docs, the one that you get through Florida Tech, which is 30 gigs. And if you just go in and create a Google account on your own, 15 gigs. You also have, we deal with Google and we deal with Microsoft here. So OneDrive is Microsoft's Google Drive, right? So their space, Microsoft Office Drive. And you're supposed to have a terabyte there. That's a good deal. That's a lot. Off the street, it's 5 gigs. It used to be higher than that. Maybe they have come down. It's still squishy, right? Things are still in flux. But once you leave, that will be a consideration. The terabyte from Microsoft might go away. So there is still a SharePoint instance here. That's also a Microsoft solution. But it's not terribly widely used. We have a SAN device, storage area network device, that you could, if you had a server to interface with it, you could use Florida Tech SAN device. Departments have their own solutions. Certainly computer science, school computing. Anybody from school computing here? No? Yeah, cool. So there are probably multiple servers through them. Now, you might have a quicker need and something that you need to control. So maybe you go buy a 4 terabyte external drive from your favorite electronics retailer. And that would work for a moment, but those are highly fragile. Those often go bad, so be very careful if that's your solution. And there are several other online solutions. We also have, anybody have HP high performance computing needs? Anyway, it's on here if you need that. We have 2 solutions currently through Florida Tech. So this is all in one place now, and people can reference it. So go wild. Use that guide, that matrix column. All right, so that was sources. And I was thinking of doing the OpenRefine demo have a little bit to say about OpenRefine before we do a demo. And Tableau, I have a little bit to say, but we probably won't do the demo. It's probably not time. Yeah, it's already 30 minutes in. So, OpenRefine. So remember, this is the data wrangling, data cleaning, data prep tool. Biggest challenge for data scientists, people who do this kind of work every day, is cleaning and organizing the data. They say it's their most time-consuming task, people who do it all the time. And it's a big obstacle for most. So, to think specifically about what OpenRefine might do for you, I ask you to consider this column of data, very small, but has lots of problems. What do you think is wrong with this picture? What do you notice? What stands out? If this were something you had to organize and you needed to create, I don't know, a pie chart or something, and this were mixed in with a bunch of other, this is publishers of actually comic books from a UK collection. But this was their, this is what was in their metadata for publisher. No problems? You think it looks good? Yeah? You're happy with it? Okay. Well, librarians will be pulling their hair out. And we have this bad habit of using square brackets. Square brackets in library land, whether it was on the old cards that we used or in our electronic records, that meant that you know it to be true, but it doesn't say that on the item. So you knew that this was a Titan comic book in this case, but it didn't say anywhere on there. Which happens, you know, publishers publish stuff and don't put their names on it, just like students do. Turn in their tests, don't put their names on it. I'll take the A. Okay. So we're going to look at what, in this mess, what OpenRefine can do in just a second. So we'll go to that. So as we'll talk about tomorrow, if you come to the OpenRefine and Tableau demo, I'll let you, if you bring your own laptop, let you load it on your own Java-enabled device. And it fires up a command line screen and the browser. The browser is your interface to working with the application, but it doesn't go out to the cloud. So it's, if you're dealing with private data, it's not going onto someone's servers. It's local. It's treated, it's operating locally. Okay, so you can see I already opened that. But here's how you would create a project. You create, you say, find this file. Let's say I have this spreadsheet of, it was Padilla, and I have him on, there he is. And open, and then next, and pulls it in. I'm gonna shrink this a little bit. Because this pane we're going to watch for some of our facets in just a moment. But you see it recognizes the columns and the headings there and keeps the data in rows, just like Excel or something. Probably use Excel for a lot of things. It's very common on campuses. And then you need to create the project. So it gives you a little preview of how things are coming in. And then you can pull it in for real. And once you see the little, I don't like this, it's hard to do the mouse on a 45-degree angle, whatever that is. So the drop downs tell you that the data came in properly. If this were a numeric file, if it recognized the numbers, it recognizes data types, so it recognizes numbers and they are displayed as a green font. So it kind of helps guide you that, oh, it came in, it recognizes what I've got there. So what can you do here? So we were worried about, or I was, you weren't, publisher. And publisher is here. And so just like you can on Amazon or Home Depot, you can say, give me all of the stuff below $20, right? And facet things down. That's sort of what you can do with multiple columns. You maybe do that in Excel, but it's usually one column at a time. Here we can do, different settings, just like Home Depot or Amazon. So cool. So this is a text facet, and we say, hey, we want to look at that, and I want you to group. Do you know what pivot tables are? So we want you to group these in sort of a pivot table arrangement. And so here's your count. Right now it's by, I'm going to step on this. Right now it's by alphabet, but you can also do it by count if you click count. And Titan is indeed the biggest one, right? It's got 3,000 some odd out of 17,422 data points. We've got, or rows, we've got 3,627 that it recognizes as Titan, and that's the biggest one. But we know that that is not clean, because we can pull down here to some other groupings and find other variants of Titan. There's Titan distributor, here's Titan book. So according to however many they include, it's not in the right place, right? The Titan it is the biggest, but it should be even higher. So what do you think we're going to do about that? In OpenRefine, they have this notion of cluster. And it will go through and say, I think these are the same. And it's pretty cool. It does its own guessing. And you can change the fuzziness. So right now it's on the most conservative one, fingerprint, and you can make it of increasing fuzziness up to that. But let's keep it conservative, and let's change these 4,000 to Titan and pretend that's okay. And Titan distributor, yeah, we'll make that plain old Titan too. So what that'll do. And this one, Titan. So it's a little time consuming, but imagine doing it one by one for 17,000 items, right? So let's say we're happy with that. Merge, selected, and recluster. Glad it's working. Okay, good. So what happened over here? Now let's get out of this. And now we've got 4,500. Still probably a lot more to go. But that's one thing that you can do with OpenRefine in terms of cleaning up the data mess that we first saw on the screen, that little sample. Let's see, let's go here. Well, I guess date will be fine. It's messy too, as you see. We have all these crazy, C stands for copyright date, again in square brackets, so it's not going to sort properly for everything. But let's look at data publication, and we'll make it a text facet. And so it's not going to give me. If it were reading these numerically, which it would take a while to convert to actual year data, then you could say, give me all of the ones from 2000 forward, and you'd have a slider for the date. With this example, it's not gonna work without cleaning it up more. And I do have other data, but we need to move on. I have another data set that would work, but so they're in this facet bar over here. You can make a lot of adjustments and narrow things down. Just like I said, on Home Depot, you can say, I only want the green ones, or whatever. So that is just a little taste of OpenRefine, and we'll move on. So the thing about Tableau is, well, OpenRefine too, really. Have you heard of the 3 V's of big data? The Gartner Group is a consulting firm for all sorts of aspects of information technology. And they analyze the marketplace and how different tools and things are working, and what trends will be. So trying to pick what's the next hot piece of software or something. So in the area of business intelligence, they have ranked Tableau very highly. But what I was going to say is, decades ago, probably a couple decades ago, they came up with this sort of characterization of big data that it is big data because of its volume, its velocity, and its variety. And people have added to that over the years, but those are the big, the original big points. So if you think about volume, that's the question, where are we going to put this stuff? And that was like the matrix chart that I showed you earlier was kind of about where to put it, what are your options. And that is more of a hardware question, right? So I can't help you much with hardware. I don't do hardware. Velocity is the question, how are we going to move it around effectively? And that has to do with the network. And if you're interested in that, I got a deal for you tomorrow also at 6:30. We're going to have a talk on net neutrality, which is a talk about the network. Have you heard of high frequency trading? They were called the Flash Boys, right? This is companies in Wall Street, because of physics, because of the speed of light, they try to get as close to where these transactions are going, and their network is closest, so they get the information first. It may be milliseconds, but they're first. Right? So I can't help you with that either. But I can help you with the software piece. So how are we going to process all of this variety, messy, all kinds of file formats, media types? How are we going to make that work? All this stuff coming from Instagram, Facebook, Twitter, all that stuff. And different devices, so it came from a phone, it came from a tablet, it came from a desktop, it came from a satellite, I don't know. So how are we going to process it all? That is what Tableau does. So that was a Tableau thing. And this was just a little from an article that talks about what are the managers of this type of thing most worried about, and in fact, it's the variety. So no Tableau, I'm sorry. So that was open data and the open data landscape. And I want to turn your attention now to research data management, which became an issue just in the last really decade or so for most university libraries. And there are some reasons connected with federal funding and requirements for that. And so this is what we're going to talk about. We're going to define research data. We're going to talk about why it's important. We're going to identify some issues, and we'll learn some best practices really quickly in the next 15 minutes. And how the library can help. So defining it, as I said. The bottom one is the official one, because that's from OMB, the Office of Management and Budget. So they're the money people that in control of the U.S. Budgets, U.S. government budgets. And they say that research data is the recorded factual material commonly accepted in the research community, so that you help decide. You're the researcher, it's your field, you help decide what you need to validate your research findings. Right? The Edinburgh definition adds that you're talking about producing original research results, which is similar to validating the research findings. So, what are the types of research data? Maybe it's observational, something that you went out to the field or your device captured and observed. Maybe it's experimental, maybe you mixed in test tubes, mixed some things together. Maybe you simulated something on a computer with MATLAB or ANSYS or one of these tools. Maybe you derived or compiled data from a mixture of different sources. So why would you do good management? Well, again, proving your research findings, so the transparency of your experiments, your research, and the integrity of that. Maybe compliance should be an issue for many of us with federal funders saying you have to do it this way, and you need to do it to be in compliance. The guy in the little cartoon at the beginning was supposed to do it to comply with, he published in this journal that says you're supposed to publish your data, but he wasn't really in compliance. So even publishers are getting on that because if they have to retract an article because the data was proven later to be false, then that's, makes them look horrible. So for their own quality, they want that to happen. And then you benefit. Maybe you're going to take on another project in the next couple of years, but you come back in 5 years to this thing you were working on, and you want it organized and a good presentation to even yourself so that you can remember where you left off. So OSTP, at least in the previous administration, was active in directing some of these things, and they haven't. These sorts of things haven't been overturned with new administration. That has overturned some of the executive orders, but these seem not to be something they're concerned about or haven't noticed yet. And so we can expect these things to be some things we should comply with. So rules of making things available is basically what these things do. Here's some examples of NIH repositories. Sometimes the funder has available a repository, and that's what you should use if that's what they require. Sometimes a certain field like genomics, those people all put their stuff in GenBank. It's just their communities, their discipline, that's where things go. We're trying to unravel genome, so let's put it all in one place. But some geneticists I've talked to said, oh, there's a lot of mistakes in there and they haven't been corrected. So, but if it's all in one place, it can be corrected over time. Not a good reason to hide it in different pockets. Just more work for the future, job security. Anyway, so NIH has several that you could contribute to. Zebrafish models, peptide atlas, all that fun stuff. So when you're working in a team, so much of science is collaborative these days. Managing your data becomes an issue of responsibility. So it's not just all on one person, the whole team has to be organized. Lab notebooks are an issue, and if you're on campus and interested in pursuing something, I think the library is interested in the topic. There are some interesting things happening in the sort of electronic notebook software world, electronic lab notebook, I should say. Jupyter, anybody use Jupyter? Things like that. So if there's some way we can help, we're interested in finding out more about it and helping if we can. So, especially on college campuses, people change every year, at least every year. So rotating lab personnel are a good reason to manage these things. So you need to define roles and identify the skills needed to perform the task, and then match that to the people in managing the data specifically. You do that anyway for your project, but data management is a specific need. You need training plans, and you need to keep records and monitor the results. So, best practices, again, we're happy to talk about some things related to that. It's an interesting topic and related to eventually putting something in a repository, right? To us, all data, whether it's digital or not, is data, right? It's information, and we want to help if we can. So contact the library. We can help you organize and preserve things. So DMP is part of a requirement for most federal funders. The questions that they ask or that they want you to answer involve the types of data. It could be sound files, could be video files, could be spreadsheets, could be many things. They want you to spell out the roles and responsibilities piece, who will own it, who will have access to it, who's responsible for managing it. Equipments and methods involved in data creation and processing. Where are you going to put it later? That's where we want to help. That's where we really want to help. Repository, yeah. So, again, the plans spell out types of data and get specific about that. They, in your plan, you should mention the standards you use, because so many fields have specific metadata standards, let's say, or file format specs that you should respect. And just like peer review in an article would kick out something in a paragraph, in your grant proposal, likewise, there might be some standards that you don't, that may raise some eyebrows, that people may question if you're not following those. So to make sure that you're, speaking the right standards and tools, you need to spell these out in your plans. So policies are important. If you can share things like with a license that says, it's okay if you use it, I just want credit, right? If you can spell that out up front, and that's what we call a Creative Commons license, is one example that would do that for you. It says, they don't have to track me down, find out my email 5 years later, or my phone number or something. I can give them permission up front, and anybody can use it. I just want the credit, right? That's how things work in academia. We get credit for things. So citing our sources is just the right way to do it anyway. So there's policies for that. There's the plans that you would need to spell out for where you're going to put the finished products, where you're going to preserve them, maybe the library's repository. Records management is an issue, becomes an issue for a lot of data. So here's an example of something that looks a lot like our Titan publisher file, but from a different discipline. So for file naming, you should be careful with that and avoid the special characters that certain operating systems may not like. Try not to use periods and spaces, but instead capitals, maybe underscores, to make it legible instead of all just a string without any kind of interruption. So you probably want to stick to 25 characters or under. Really long file names can be a problem. And date format. I love this date format. First the year, 4 digits, then the month, 2 digits, and then the day, 2 digits. It really helps to sort files if you use it with discretion. Version numbers might be something you would put in a file name to distinguish an older one from a newer one. Here's an example of from Hart research. So A for apex, B for basal, then they use the experiment number, mix that with the A or B, and then they have some section number, and they may add the type of stain that they included there. So that's just one small example of a file naming convention. So we can help. We're happy to help. Metadata is especially a library specialty, so making sense of your data eventually is your goal. That's the goal of preserving it. So you need to think about metadata standards. You need to think about how you're going to describe a data set so people can find what you have in there. REDCap is, especially med schools, I think, use REDCap for, here I think it's Qualtrics is sort of similar, so an instrument for gathering like survey data or patient data. So they have information on their data dictionary here, so if you're thinking about a survey of a bunch of people, how are you going to organize it? You have all of your data fields described with examples here. And branching logic, for surveys, if-then sort of things. You've got that spelled out so that it can at least make sense of, wait, this response doesn't have this information, but this one does. Oh, the logic said that. If they said no, they go over here. Okay. So here's a metadata record. This is called DC is Dublin Core, and here is some subject data there, and it's got a title, it's got an embargo. Is it, wait a minute, don't send it out until the article appears, don't make it available. Keep the data under wraps until we publish our work. Okay. And tracks the usage. 8 page views already. Here's an example for flies with their metadata records. Maybe that's interesting to you. So, make sure you describe the contents of your files. Make sure you define parameters and units of measure for the parameter. Explain how you're formatting your dates, your times, your locations, and any parameters that may use some kind of coding. So define any coded values if you have a special, unique coding system. So, good practices. It's good to keep track of all these sorts of things. This is basically Dublin Core, I think. So, backing up is a good practice. Just about done here on time, so let me wrap up zip through these things, and then I'll show you the one Tableau thing I wanted to show you. So, backing up is important. The matrix will help you with the space you can get and places to do that. For preservation, we recommend 3 copies that are geographically distributed, at least in one case, and on a variety of media, possibly in the cloud. It might be a good idea if you can. So unencrypted, uncompressed, be the best way to go. So intellectual property is an issue. Those things need to be spelled out. If you talk to your IRB, let's say you had human subjects and you have data on that, there are some rules for that you need to follow. Your funder may have some rules, and your publisher may have some rules, and there may also be other laws. So here's a retraction example. They couldn't provide the original data, so it had to be retracted. Very embarrassing, not good for your career. They were unable to provide the original source files. So their best practices may depend on your context. So here's some IRB examples. The first one is an IRB example. 3 years after the completion of research is your retention period minimum. HIPAA requires a minimum of 6 years after signing an authorization. FDA is 2 years beyond marketing the application for it's in a drug approval process. VA, retain indefinitely. So you need to be aware of your context to know how long you need to retain things. So that's just go on. So we can help. I said that already. Open formats. Don't use proprietary formats or software that will produce proprietary formats if you can help it. Sometimes it's, you know, if you're buying a special, I don't know, electron microscope and you're limited to what maybe 2 or 3 manufacturers will produce. But we'll do our best with what we have and try to kick out unproprietary formats when we can. Okay, so let me zip through. We can help. I said that already. Works cited for all that stuff. Okay, here's the Tableau example I wanted to get to. So with all of this data everywhere, if you help, and we make so much of this stuff open access, and we can plug into data from everywhere, here's an example of, imagine a newspaper that was every newspaper. Imagine if you could accumulate all the stories by geography and kind of rate them in different ways on a scale. So here is, so this is just a screenshot. We can go to the demo here. But you see, this is like number of stories, intensity of stories. This is 2014. This is on a map, putting the stories in clusters with the circles. And here, social media again, here is like sentiment analysis. So the people in Belarus were really happy about this, but the people in the UK were upset, or something like that. So if you want, I can try your country if you like, or a country you are welcome to suggest. Uh-oh. Oh, yeah, pick a country. I think you can do it. Yeah, it's still active. So, 2014 was a big year. That was Ukraine stuff, but it was also things in Nigeria like Boko Haram. But we could go to, what was it? Oh, when I was at Eastern the other day, she wanted to go to Trinidad, so happy to do something like that if you like. Any other? Scott Tilley wanted to do Canada when I did this for. So Trinidad. All right. So with sentiment analysis, you can see, wow, whatever happened in Trinidad that year, Jamaica was not happy. But U.S. was okay with it mostly. So imagine if you could let's get over there. If you could drill down to each case, you know, I mean, there's a story behind these are sets of stories, so imagine that you could drill down to each story. So whether it's a newspaper or something else in your field that provides you know, some way to accumulate all of this data in some way, put it in a dashboard, and allow you to zone in on exactly what you want. And this is sort of just an example through Tableau of things that could be done. So this at least gives us hope for why we're doing all this open data. Hope that is not too fuzzy. It's a really exciting time. And happy to talk to you about open data and managing it. Thank you for coming. Any questions? Data humor again, sorry.
So are you going to have the slides available, or this recording will be available?
Sure.
Okay.
Yeah, we got Panopto going.
So on the library website?
I guess the YouTube channel. Thank you. Thank you for coming.
Not even